scope 1, scope 2, and scope 3 emissions, because in the even the operation of a green building or before that the construction of the green building, this scope 1, scope 2, and scope 3 emissions can play a significant role in reduction of the emissions. And these accounting practices must be integrated with the not only in the design phase but in the operational phase as well. Now coming to the integration of the technology with BIM, building management system, IoT, and finally AI, because today everything is evolving around the next gen technologies. So integrated building management system can play a very, very significant role in monitoring the entire life cycle of the asset. Because many of you might be aware that IBCs have already drafted a handbook on BIM. Now finally to the economics part. So in case of an energy efficient green building design, construction, and operation, there may be initial capex that may be a bit higher. But ultimately, we can leverage the building's energy consumption, reduction in building energy consumption to the extent of 30 minutes, and water cost to the extent of 50 to 60 minutes. Dr. Anil Joseph, in the first session, he has mentioned a very important point. Maybe the next world war will be on the crisis of water globally. So this combine these effects, this can be not very high payback period. This can be achieved within 3 to 5 years of payback period. And it can also lead to a reduced maintenance, and it can enhance the integrated asset value, because we all are our main focus at this point of time for a life cycle asset approach, not only on the initial investment. So these are the basically conclusion and the sustainability roadmap. And for thanking you all for this patience hearing, because it is very difficult to stand between the last session and the lunch.
Thank you so much.
Thank you all.
Now, I would invite Dr. Madhura Yadav. She is an educator, academician. Presently, she is working as the Dean, Student Welfare at Manipal University, Jaipur. She is IGBC Fellow and Sustainability Expert. She is also an expert for Bamboo Techno Commercial Report for Niti Aayog and is working with BFIS for Bamboo Handbook. Over to Ma'am Jadhav.
Namaskar and good afternoon to all of you. Actually, energy efficiency is a very vast, but as an architect and planner, I restricted myself for the building envelope and the material part of it. I am working for materials, but here I just focused on building envelope, materials, and case studies of different buildings. So there are various terms like green building, then environment-friendly architecture or eco-friendly architecture, solar passive architecture, or climate-responsive architecture. When I studied all these terms, what I came to conclusion that the paths are different and it leads to sustainability. So sustainability makes a scientific term. All the rating systems are there in the world. We have compared that, and we found that in one rating system, the building is platinum rated, and in another rating system, even the building is not certified also. So we identified the gaps and then proposed one system, which we called as a Bharat rating system. That work is also completed. So there is a question in mind, is sustainable building design, construction, and operation costly? And people feel that, yes, it is costly. That's why it is not accepted by people. But I am happy that today in the our Honorable Minister has insisted on that ancient architecture, water conservation techniques of ancient India. And I also feel sometimes this whatever education is there, engineering, architecture, planning, this education came into existence, I think, 150 or 100 years back. But all these buildings like Havelis or Vadas or forts or any cities, like Jaipur is the first planned city of 18th century of India. And Jaisalmer is a town in Rajasthan. Or any other cities of India, like Bhubaneswar is there, Delhi, Old Delhi is there. So that time there were no planners, there were no architects, but still these cities and buildings are sustaining till today. And we have to take lessons from that. So the structure of the presentation will be the problem, buildings and energy, the insight envelope as interface. The pillar one is orientation, pillar two is materials, pillar three is active passive techniques, pillar four is very important, that is landscape. And the last part is synthesis and recommendations. I think my predecessors have covered many aspects of this, so I will not go into the detail of it. So as we all know that global energy consumption trends and building sector is the most important sector which is consuming energy a lot. So there are two types of emissions, that is embedded carbon and operational carbon. So embedded carbon is basically GHG generated from the entire life cycle of a building, including its manufacturing, transportation, installation, maintenance, and disposal. Whereas operational carbon is the GHGs emitted to the atmosphere from the building's use of energy from the utility company, then whether it's electricity, natural gas, diesel, fuel, or even chilled water, steam, or heating hot water from a central utility plant. Now, if we take the example of resources, we take a example of land as a resource. We are seeing that if the building footprint is less in the city on that particular land, but what about the land which went into preparing the materials required for that building? That is 100x times. So building footprints are also important. I have worked on the ecological footprints also. So take water as a resource. We are using waters like in buildings and 24 by 7, whereas the water is scarcity for the poor people. Land also is scarcity for the poor people. So there is no problem of resources. I think we have a problem of equitable distribution of resources. That is, ecology and equity is very, very important. Now, energy is viewed as mechanical issue. So the focus is on HVAC systems, then automation reliance. Then there are some overlooking passive architectural elements, that is building orientation and materials, then local microclimate. And inefficient building despite green technology because of the high operational cost, then technology failing to solve the design flaws. Now, identify the critical research gaps in the energy analysis is material construction, then the exterior envelope, then systems, example, lighting and HVAC, and landscape as a site. And then it's like three areas where narrow energy scope is there, that is limited to operational energy use. Then there is a gap. We are looking at all the things isolation. We have to integrate all these things and then only we can talk about sustainability. So there is a lack of holistic view, that is missing comprehensive environmental framework. And then system fragmentation, what is lacks of embodied energy data, then ignores landscape impacts and excludes interior systems. So as already discussed, all these phases of life cycle building, that is production, construction, use, and end of life. So paradigm shift is required from conventional to propose, that is HVAC first to design first, then reactive to passive, and from fragmented to integrated. So establishing a framework linking performance, material, design, and site ecology are equally important for holistic integration. That is envelope systems and material systems, site ecology, and interior design. So in envelope systems, we talk about developing a technical framework for envelope performance that ensures structural integrity and efficiency. In materials, that is integrating the advanced materials to enhance the sustainability and building. functionality throughout the project. Site ecology, analyzing site ecology to create buildings that respond to the natural systems and minimize their overall footprint. Whereas interior design is designing interior spaces that optimize occupant comfort. Nowadays, there is a concept of healthy buildings also, and that is which is very important. And well-being, because building syndrome, the sick building syndrome is there. If we are in a building which is fully AC and there is no connection from indoor to outdoor, so that is called as a sick building syndrome. So there has to be connection between the indoor and outdoor. That is which is very important.
Ma'am, 2 minutes.
Oh, sorry. So I'll just go to the building envelope. In building envelope, there are three important elements, which is orientation of the building is very important, as is spoke by our chief guest and another minister also. We have to orient the building as per the site, sun and wind of the place. So that is very important. There itself we cut down the demand on energy if building is oriented with respect to the solar and wind of the place. Then in building envelope, there are three components, which is wall, roof, and doors and windows. If we take care of these elements, in each element, there are certain things like wall, the thick materials of the wall, then construction techniques of the wall, what kind of you are using for that particular climate, then roof also, shape of the roof, material of the roof, and construction technique of the roof. So these are these are elements, and doors and windows, as spoke by my earlier speakers, window wall ratio is equally important. So this forms the envelope, and I'll just go through the examples. This is Kerala's traditional house for the roof, then Auroville art architecture. This is a very important and which is very close to my heart. This is a residence of one Malaysian architect, Dr. Kian Yang. I read his book, Tropical Urban Regionalism, and I got inspired for my PhD to take architecture ecology interface. So this is a net zero house, and then materials also plays very important role. I'll just skip and then go to the materials tag. This is also a very famous example by Charles Correa in Mumbai for Kanchenjunga apartments orientation, how the building should be oriented in particular climate. Then this is Al Baha Towers of Abu Dhabi. This is also dynamic facades are there. So they move as per the solar radiations and the building is energy efficient. And I have also compared that what are the initial cost, energy saving, cooling load and solar. Then there are different techniques like recessed wall, flat wall, thick wall, then dynamic facades. For building and fenestration also, window to wall ratio is very important. Then there is a Manitoba Hydro Place in North US. This is also a very good example. Then Build Center in Seattle, Indira Paryavaran Bhavan in India. Landscape, for this, I would like to give the example. This creates a microclimate, that's thermal regulation, air quality and carbon, that's stormwater management 55. So vertical garden is also, greening system is also there in buildings. So there are some examples of, again, Kian Yang, that is Minara Misianega, then ST Setia at Malaysia, and Irit Tower at Singapore. I think he is the one architect which is practicing, and whatever he is researching, he has implemented this in practice. So there is one book, Thinking with Skyscrapers, Eco Skyscrapers. So he has proved that even the skyscrapers can be designed with zero energy. And this is again the most energy efficient building.
Ma'am, conclude,
Yes,
please.
yes. Our university is also one of the examples. So there is a framework at the end. One is we have to do the climate analysis, then envelope integration, roof optimization, facade depth, then material selection is very important, interiors and landscape systems, then performance, then balance of active and passive and active, then life cycle. Thank you.
Sorry, we could not give time. It needs 1 hour next time. So I will request now Dr. Sandeep Chowdhury, Professor of IIT. He is Dean Administrator, Professor in IIT Indore. more than 20 years of academic and research experience, PhD from IIT Delhi and postdoctorate from South Korea, published more than 120 papers in SCIE journals, and carried out more than 25 research projects. Holds the first technology transfer by IIT Indore, has collaboration with 15 countries. Over to Dr. Chaudhary. So 10 minutes, please.
Yeah, please. Sure. Yeah, thank you. And I think it will go. Thank you. So I'll just touch upon two technologies which we have developed. And as the speakers have said, whatever they have said, we have tried to implement those in our technologies. And why it is important, because often there is a gap between academia and industry, but somehow we have been able to bridge that, and whatever technologies we have been developed, we are happy to tell that they are being used in the industry and by very prestigious organizations. These are some of the technologies which we have developed, but I will just pick up two technologies here. First is which happened with the first technology transfer of IIT Indore. It's based on a very simple concept. We have developed a bi-layered colored brick where we imparted color to each brick. And the reason behind that is fired bricks, we know clay bricks, they have all the disadvantages except one advantage, that they are auspicious. They have the auspicious red color. Whereas unfired bricks, fly ash bricks, they have all the advantages except that they are gray in color. And if you think about rural population, mostly they don't have that much liberty or leverage to plaster and paint the outer faces. So the key challenge is aesthetics of unfired bricks. Can we have some low cost material which fits into the budget of brick mixes, which is very low cost, in fact, 1 to 1.5 rupee per kg? And then the solution should be economically competitive, and there should be a manufacturing feasibility which fits into the existing setups which the manufacturers have right now. Then there was another motivation of using color from stone waste, because they have inherent color. They have originated from durable stones, and there's availability of dimensional stone waste in huge quantity. But having said that, it's not that easy. We have to understand the entire production cycle of waste incorporated unfired bricks. We try to work upon all the aspects. I'll not go in much detail because time is very little, but we worked upon all these aspects. And the first question was why industrial scale waste utilization is very limited, because there is insufficient characterization, manufacturing parameters are not well defined, economical viability is not well defined. Carried out the characterization methodology. This is more from research point of view, so I will skip that. These are the four stone waste which selected: Dholpur stone waste, Jaisalmer stone waste, Kota stone waste, Makrana stone waste. And along with that, another challenge is why we use just fly ash, because now it is not that much available in abundance. Why not? We cannot use other type of fuels, so we worked upon different fuels. Another challenge with fly ash is, as of now, like for concrete, we have IS 10262, the concrete mixed design codes. But in fly ash or any other ash, there's a lot of variation in the ash which we get from day to day. So there's no as such mixed design code. So we try to work upon that. Use different characterization technologies. Selected 6 different industrial ashes. One is fly ash and 5 different type of other ashes. Carried out some tests. And of course, when we are using some new material, we have to have a proper mixing sequence also, because we are incorporating waste and new ash. So developed a mixing technology, different mix proportions. This is like we can see compressive strength of unfired bricks. All the bricks have more than 10 Newton per unit square strength. And this is the mix design which we prepared. Time is less, so I'll not go in detail. But this is, you can see the compressive strength result of different colored geopolymer mortars. Each mix has a strength much more than 10 Newton per mm square, which is our requirement. This was the conceptualization that only top layer will be colored to reduce the cost. This was the cost analysis, and if we see this complete cost analysis, and if we see include the saving in plaster and paint, save a good amount of money. Like if it is coming 7.23 rupees per brick plaster and paint, here for bilateral it comes out to be only 4.74 rupees. Of course, it's a 3-year back calculation. And then because we are using now 2 layers, we developed a step-by-step manufacturing method, which should get fitted to the existing manufacturing setup. This also we're able to develop, and these are the final bricks which we have developed. These are being used. We have transferred the technology, and of course, this was like recognized as one of the top 40 technologies by IIT Madras last year. This is a follow-up work. I do have a video here, but I'll not play that. It will take time. But what we are doing is now we are creating or developing a furniture which is made from 100% waste, and it is demountable furniture like any other plastic furniture, and it will be 100% waste. So this is how we can develop these round tables. I skip that. The another technology which is now very prestigious defense organization in Pune is GoBear, where we have used cow dung powder as a natural foaming agent. And this is the journey, like, there are different TRL levels from identification of challenge to control demonstration. We have been able to reach to the final level. Challenge is very simple. We have a lot of goshalas. They're not sustainable because they're not able to sell cow dung at a proper price. So can we help them out? So we came out with a solution. There are a lot of properties of cow dung. One of the properties which can be of use for a civil engineer is high moisture retention, and it has internal curing applications. So that was the focus of discussion. Concept is very simple. The cow dung powder, it absorbs the moisture, and once it goes in the brick, it will release the moisture, it will make the brick lightweight, and it will make it strong also. So this is the concept validation through microstructure image. Very simple proof of concept. We can see the foaming action here. And of course, then we have to standardize the product. So we
2 minutes, sir.
yeah, please. So we have standardized the product also. This is the powder which we have developed. This is a small product video, but I will skip that. Novelty, it's the first foaming application of cow dung, results in thermal insulation, eco-friendly, low cost, easy to use, no requirement of autoclaving machine, manufacturing process simple and scalable. Of course, whenever we develop something, it has to be like validated or it has to be benchmarked with existing technologies. So it's benchmarked with ready-made foaming agent. We can see a lot of advantages are there with this GoBear. And these bricks, here you can see a comparison with AAC block, foam concrete, lightweight aggregate concrete GoBear. So here we can go up to 3A and with reduction in density up to 1400 to 1600 kg per meter cube. So it's a win-win situation where we have a good strength as well as a good reduction, and it's low cost also as compared to the conventional solutions. We developed a technical manual also for facilitating its field application. And of course, like sometimes we may require more lightweight, sometimes we may require more height, more strength. So we have developed different mixes. Like you can see on top, it's lightweight at similar strength and cost. And then there are different combinations. And the last one is industry approved trial, which is being used by that organization. We have given two models also as a for manufacturing setup because finally it has to be economical viable. So these are two manufacturing setups. Rural scale industrial trials are already going on. We are training already a rural population in the nearby panchayat, Simrol Panchayat in Indore, where we are located. Department of Science and Technology has given funding under the scheme of Shramik Vikas, and this has been widely appreciated. And this is the wonderful team. And I would like to acknowledge one of my students is sitting here. He's very senior officer in Indian Railways. He worked on this in 2012. Praful, you are here. So he came just to listen to this seminar. 2012, he worked on activated alumina sludge in bricks, and since then the journey is on. He got some prize from Motorola Foundation also. Thank you, everybody.
Congratulations. Thank you, sir. I would request again questions answered or to be short. Please address the presenter to whom you want to. We can take a couple of questions quickly. Any questions, please? Mrs. Sangeeta Pani from Odisha. Please address your question. Mic to her, please. Please address to whom?
Sir, my question is to sir on cow dung bricks. Sir, my question is how it behaves to the moisture?
How it
Behaves to the moisture in comparison with other bricks.
it is like we use it as a dry powder, not as a wet. So when we use it as a dry powder, so it has then a capacity or it has a tendency to absorb moisture. That times it absorbs moisture.
So,
Once we make brick out of that, it releases that moisture.
so sir, what about the curing? Then it is all.
Curing is almost like internal curing. It itself is giving internal curing. That's the beauty of this solution. Because whatever water it releases, it is already inside the brick. It cannot come out. So that is used for internal curing. And it creates voids, which makes it lightweight. And because there is more internal curing, so that increases the strength also.
Okay, sir. One more. Sir, is it treated with lime or cement mix composite with the cow dung?
I could not get.
Sir, whether the product is tested for cow dung only or again it is mixed with lime and cement and other
No,
products?
it is with existing, whatever existing bricks we use, we just add powder of that. A very small powder, you can think about 1% of that bit.
Okay.
Just addition, additives.
Okay. Thank you, sir.
Continue the discussion.
Excuse me, sir.
Yes, sir.
Yeah, excuse me. Did we try to make color the AC blocks?
Colored AC blocks.
Yeah.
That we have not tried. But right now we are trying those who are from Northeast, they might be knowing Captain Steel is a big brand there. So they have approached us. So they have asked us to develop colored GoWare bricks. But we have not tried colored AC blocks.
Thank you. I think we have to conclude with my perfunctory duty of the chair's conclusion. It has been a very good session here. The sub-theme was energy efficiency in green buildings, and the Energy Efficiency Act was enacted in the year 2001, sir. So, Mr. P. Suresh, the doyen of this energy efficiency national building code, with his hardcore background, has already presented the whole scenario where we were, how we are progressing, where we will reach. Backed by the morning session 1, and the soul-stirring deliveries by Honorable CM and PWD Minister, we are now progressing with this session, and all the presentations, the keynote is by V. Suresh sir, were very interesting. And the last one spoke about Dr. Chaudhary. He spoke about the GoWare and that four-part comparison statements of ACLCA, GoWare, and others was really revealing, and it holds promise for alternative materials, green material across the country. In the initiation, Suresh sir spoke about NBCS 20T6, where the sustainability and development rules will be in the next volume. Okay, that we'll be waiting. The entire stakeholders of the built environment, including Indian Building Congress, will be awaiting. And I was discussing with him, all chapters have a bigger role now to progress with sensitization on this NBCS 2026. IGC vision achievement 32 rating system covered so elaborately and really educative for the new delegates who come from different parts of Madhya Pradesh. I'm sure they have learned a lot on this. And coming to Engineer Anirban Datta, well, again, he gave the thrust on integrated approach, green efficiency and sustainability, not isolated subjects. And he also referred to the global impacts. architectural planning also, he said, and which was later elaborated by Dr. Madhura Jadhav. I was not the guy. He could have at least given another half an hour time to elaborate on that. And Bharat rating system, that is what see the takeaway from here. I think in the recommendation of today's session, it should be included. Ancient buildings, old Indian cities, how sustainability was ingrained. And that, see, again, gave the thrust on that. And the whole architectural design process from the beginning, which was traced by Engineer Manoranjan Mishra in the first session, uh, that should be the thought, how to reduce waste, how to reduce the energy in the energy consumption. And she has elaborately presented that, including the orientation of the building, alignment of the doors, windows, all these things. And the paradigm shift from the envelope, including envelope, site ecology, material, and interior. That is the takeaway. Uh, Lastly, as I said, Dr. Chaudhary, that cow dung powder as natural cooling agent will be a great takeaway, and that should form part of our recommendation also. Thank you. I would request my colleague, Mr. Suresh Bairua, to also speak, co-chair, please.
So the detailed analysis has been done by Sri B.C. Tripathi, Vice President, IBC. In the second session, core presentation has been given. First presentation by Steve Suresh, former President IBC and ex-chairman HUDCO. He stressed upon energy efficiency in green buildings, green infrastructure in cities, low carbon environment, green building materials and green